international event of the International Society for Energy, Environment and Sustainability. As most of you know, and I'm sure Dr. Saraswat must also be remembering that the main aim of our society is to bring sustainable development, in particular in the area of energy, to provide clean and affordable energy, as well as to provide sustainable environment to public. The society has been disseminating scientific knowledge through persuasion of conferences, as well as through persuasion of specific designed lectures. And this is how this is the 5th international event which we are organizing. Of course, this year it is a virtual event. All of we know that it is because of pandemic, which all over the world everyone is facing. So this conference continues to address the same issues, that is sustainability for energy and environment development, and in particular with focus for national needs, and put in perspective what could be the future and where the sustainability lies for India. This would be specifically addressed in one of the panel discussion, which is the last session of the conference. In this webinar, we have a very huge response, and approximately 500 delegates have registered and attending this webinar, which started this morning. So I hope all the participants would enjoy attending this webinar, international conference, that is SEEK 2020, and would be benefited by lectures which are being given in different sessions. In fact, it is a kind of 9 different themes have been prepared, and there are national and international experts who are giving invited talks in this different thematic sessions. So with this, I would once again invite all of you to actively participate. If you have any questions, etc., as you know, in webinar, it is possible to address questions by typing into the menu box, whatever is there, and session coordinators will take it up as and when the time permits. So with this brief, I would request Dr. Agrawal to proceed further onto this one, which is the most important, one of the most important aspect of our society's annual awards. Dr. Agrawal.
Thank you, sir. Thank you. It's as you all know that we honor different people for their contributions to the area of energy, environment, and sustainability. And every year we give out the awards, but unfortunately, due to pandemic, we will not be able to give the awards and recognitions to various awardees. However, we would like to announce the awards and give away these awards whenever there is opportunity to give away the awards in possibly in the next conference, which will be held physically sometime later next year. And we promise to bring Dr. V.K. Saraswat to give away these awards in the next conference. So as you know that we give awards for young scientists below the age of 35. And this year there were very large number of applications, out of which we have selected 2 candidates to receive this award. And the first award for the ISES Young Scientist goes to Dr. Nitin K.S. He is a faculty in National Institute of Engineering in Mysore, and he works in the area of advanced materials of commercial significance. The second award goes to Dr. Arup Jyoti Bora, who is currently working in Tejpur University. And he did his PhD from IIT Guwahati, and he works in the area of waste to energy, biopolymers, invasive plants, circular bioeconomy, agriculture, solid waste, and carbon and climate studies in GIS. The best PhD thesis awards also, there were a very large number of applications. And this year, the committee under the leadership of Dr. Amit Agarwal and the other members were Dr. Tarun Gupta and Professor Adi Tyagi from Canada. They have done the shortlisting and selection of the awards for best PhD thesis as well as young scientist. And the committee decided to give away awards to 4 people this year for best PhD. So the first award goes to Dr. Arvind B from IIT Bombay, and his PhD thesis is thermoelectric power generation using microcombustors. Second award goes to Dr. Pooja Sharma. She has submitted PhD in Babasaheb Bhimrao Ambedkar University in Lucknow. And the title of the thesis is Bacterial Assisted Phytoremediation of Organic Pollutants for Detoxification of Pulp and Paper Mill Effluent after Secondary Treatment. The third Best PhD award goes to Dr. Ranjana Sirohi from GB Pant University of Agriculture and Technology, Pantnagar. And the thesis title is Process Optimization, Characterization and Modeling of Microbially Synthesized poly-3-hydroxybutyrate using damaged wheat grain. The last Best PhD award for this year goes to Dr. Shantanu Basak of Indian Institute of Technology, Delhi. And the title is Studies of Sustainable Approach for Developing Fire Retardant Cellulosic Textiles Using Plant-Based Bio Macromolecules. As you can see, these are all working in different, these individuals have made significant contributions in different aspects of energy, environment, and sustainability, and we heartily congratulate them for this recognition. The next important phase of this honoring ceremony is to declare the fellows, and as we know that people who have made distinct contributions to the areas of energy, environment, and sustainability, society honors them by declaring them as honorary fellows, and it's a very, very rare honor given by the society. And this year we are very happy to declare that the first SAE honorary fellow is Dr. Rakesh Kumar, who is director of NIRI Nagpur. Dr. Rakesh Kumar has made significant contributions in the field of environmental science and engineering, which has wide spectrum such as air pollution, control and management, water and wastewater treatment, hazardous and municipal solid waste management, environmental impact assessment, environmental audit, modeling, health and climate change. The second honorary fellow for this year is Professor Hamid Matgalchi. He is Director of Energy Systems Engineering in Northeastern University. Professor Matgalchi works in the area of thermofluids, dealing with scientific issues in power, energy, combustion, fluid mechanics, thermodynamics, and chemical reactions. And he has been at the Northeastern University since 1979, served as chair of Mechanical and Industrial Engineering Department from 2004 and to 2012. And he has many people working in the area of thermal engineering have studied the Matgalchi-Keck correlation for flame speeds. So he's pretty much known for his scientific work in the thermal science community. The fellows for this year, this was the executive committee has finalized that this honor will be bestowed on six members of the society, and they are declared as the fellow of the society for 2020. So our first ISWS fellow is Professor A.B. Gupta, who is a professor of civil engineering at MNIT Jaipur. He has contributed to biological waste treatment technologies, environmental health and environmental modeling aspects, and made significant contributions in these areas and large number of publications. The second fellow of the society for this year is Professor Indu Shekhar Thakur. He is a professor and former dean of School of Environmental Science at JNU. He has made significant contributions in the area of environmental science, and he has received many, many awards and published extensively in these areas. The third fellow of this year is Professor Shishir Sinha. He is professor and head of Department of Chemical Engineering at IIT Roorkee. He has made significant contributions to the area of blended polymer composites, polymer surface modifications, polymer composites, nanocomposites, ion exchangers, etc. And he has made a large number of contributions to chemical engineering. The fourth fellow for this year is Professor Sudarshan Kumar. He is a professor and head of Department of Aerospace Engineering at IIT Bombay. And his research interests include computational fluid dynamics, transport of smoke and other pollutant species, and reduction from the combustion devices and furnaces. And he has made some extremely good contributions in the area of development of microcombustors for a variety of applications. The next fellow is Professor V.K. Garg, who is a professor at Central University of Punjab. He has made extensive contributions in the area of water and wastewater pollution monitoring and treatment, solid waste management, pesticide pollution, heavy metals, and radionuclide pollution. And he has also made a lot of publications of high impact in a variety of journals. The last fellow for this year is Professor Yogesh Chandra Sharma, who is a professor in Department of Chemistry at IIT at Banaras Hindu University. He has made extensive contributions in the area of renewable energy and biofuels, development and characterization of heterogeneous catalysts, synthesis of nanosorbents, river health science, and monitoring of river Ganga. So with this, we conclude the ISWS award announcement ceremony, and we are looking forward to honoring them in person in the next year's conference whenever things are more suitable and more conducive for having a physical meeting. So with this, may I now request Professor Gautam Kalgatti to share a few words before we introduce our chief guest. Professor Gautam Kalgatti is...
Yes, I will, 1 second. I mean, I have to unmute my... Right. Good morning, everyone. I mean, first of all, I have to congratulate the organizers of this conference for getting together such a very interesting and good program at what seems to me to be an extremely short notice. I mean, and it's very, very well organized. Really, congratulations to Avinash and Akhilendra and everybody else who's been involved in this. And it gives me great pleasure to, of course, to see Professor Dr. Saraswat again and listen to him. I heard him in Bangalore about 3-4 years ago, 2017, I think. And I don't want to take any much more time on this. And please, Avinash, start the session and I'm eager to hear what Dr. Saraswat has to say.
Thank you. So may I now request Professor Ashok Pandey, Chairman of ISWS, to kindly introduce Dr. V.K. Saraswat. Although he doesn't need any introduction, he has been a patron of our society ever since we started the society. But on a formal note, may I request Professor Pandey to kindly introduce the chief guest today.
My request is my introduction could be as short as possible.
Thank you, Avinash, and thanks indeed, Dr.
Professor Avinash, I would request that.
Dr. Saraswat is a scientist of international renown and an accomplished researcher with more than 4 decades of experience spanning over several fields. He has completed his basic education from Gwalior, Bangalore, and thereafter from Hyderabad. During his illustrious career, he held the twin positions of scientific advisor to Defense Minister and Director General of DRDO and Secretary Department of Defense and Defense R&D. Dr. Saraswat has served as Project Director, Prithvi Missile, and Program Director, Ballistic Missile Development Programs. He has done very pioneering work in indigenous development of many defense systems. Dr. Saraswat has been honored with the Padma Shri in 1998 and thereafter with the Padma Bhushan in 2003. He is a recipient of many other awards. Currently, Dr. Saraswat is a member Niti Aayog and Chancellor of prestigious Jawaharlal Nehru University and shouldering many honorary positions in Government of India and academic institutions. Thank you. I request now Dr. Saraswat to kindly bless us with his inaugural lecture.
Thank you, Professor Ashok and Professor Avinash, for inviting me for this conference on sustainable energy and environment I have been a regular speaker on this particular platform, thanks to Professor Avinash. I think it has been 3 or 4 years since I have been associated with this. So while I cannot add something very extraordinarily new today, but certainly today the scenario as far as the energy is concerned, mobility is concerned, security of energy is concerned, environment is concerned, it is a major issue across the globe. And what India is doing in this context and what technologies are required to reach the levels which are expected, because all of you know that India has signed significantly, has signed the agreement on the international platform COP21, where we have made certain commitments to reduce our carbon dioxide emissions and switch over to energy mixes that will reduce the environmental pollution. So my talk today is basically with respect to what are the energy needs and what are the kind of technologies which we need to do and how we should actually develop that. So I would like to share my screen. I hope I succeed. Let me see if I can do that. Are you able to see the screen?
Yes, we can see.
Yes.
Yeah. So we are going to talk to you now on this. I'll make it full screen now. Let me see. I hope succeed. Yeah. So technologies for energy security and sustainability. You know what is the current scenario of India's energy? We have oil import dependence, which has risen from about 82.9% in 2017-18 to as much as 83.7% in 2018-19. I think the figures of 19-20 will be similar. The energy consumption to grow almost 4.5% every year for the next 25 years. That is the kind of analysis we have done. And expenditure on crude oil, $120 billion and $102 billion in 2019. Not that the requirement came last, but actually the prices of oil reduced. So as a result, we have less outgo of the foreign exchange. So you can see our dependence as far as energy is concerned is significantly on the imported oil and things like that. So there is a change in the energy mix today. India is moving towards a robust energy mix, focusing on sustainable energy resources such as solar and wind. By the end of 26-27, India is projected to get around 43% of its total installed power capacity from clean energy sources. If you see now, we have, as on today, installed capacity is close to about 373 gigawatts, and we intend to reach about 640 gigawatts by about 26-27. And as far as if you see the distribution today, you will notice that among all of them, renewable is presently 88 gigawatts, but likely to reach about 275 by the end of this particular decade, which I'm talking of 26-27. Hydro is 45.6. And then reaching about 71. Nuclear, we don't have much at the moment, 6.7. Likely to go to 14.8. I've always put a question mark on this because the time required for setting up the nuclear power plants have always been very high. And of course, there are priority issues as far as this sector is concerned. Then we have the gas consumption, which is gas-based oil, gas-based production, which is about 24.9 today, likely to be 29. You can clearly see that this is one segment which is not going to grow much. But coal, which has been a predominant source of energy for us, because today it's about 205 gigawatts from coal and likely to reach 248. Yes, the growth will not be as significant because the renewables will take over, but certainly coal will continue to play a major role as far as the energy production is concerned. Now, if you see the energy mix, as we have seen earlier, August 20, you'll see the coal is about 55.3, and it is expected to go down by 26-27 to about 38%. Renewables, which is about 23.9 today, will reach about 42%, 42.9. Hydro, which is about 12.3 today, will go to slightly less, 11.2, and so on. So this is the kind of change which is likely to take place as far as the energy mix is concerned. And in percentage forms, we can say that thermal, even today, by about thermal scenario will be about 73%. And more out of this, more than 80% will be from coal, and about renewable will be about 14.5%. This is the kind of distribution we have as far as the electricity generation from various sources in India is concerned. So how do we transit? How do we go from there to a level so that we can meet all the commitments which we have made? For which there's a transition strategy for every nation has worked out, and every nation has come to a conclusion that renewable-based transition is the cheapest. And renewable as cumulative investments have been to the tune 2016 to 2050 US $1 trillion. That is the kind of numbers. If you see the distribution, it's about $110 trillion is what we are talking of, needed by 2050. It is equivalent to 2% of the global GDP per year over the period, out of which about $26 trillion will be in electrification and infrastructure, $27 trillion will be in renewables, and $37 trillion will be in improving the energy efficiencies, and of course, others will be about $20 trillion for alternate fuels and others. So this is a kind of scenario which is emerging across the globe through when they are going through what is called the renewable-based energy transition. Every dollar spent in the global energy transformation saves about $3 to $7 US as far as this transition is concerned. So what is the Indian perspective in this particular context? Indian perspective is in one of the few countries, India, in the world to have made consistent year-on-year progress since 2015. You have been seeing that our renewable is increasing, and in fact, in the last 2 years, it has been significantly higher. And now our 175 gigawatts of renewable goal, we are now talking of 450 gigawatts by about 2025. So this is the kind of scenario which we are creating as far as the transition is concerned. India's improvements have come across all three dimensions of the energy triangle, that is in economic development, energy access, as well as environmental sustainability. The World Economic Forum has said that emerging centers of demand, such as India, which in terms of demand we are 74th, has made consistent efforts to improve the enabling environment. So we are being reckoned as nation making efforts. For India, gains have come from a government-mandated renewable energy expansion program, now extended to about 275 gigawatts by 2027. India has also made significant strides in energy efficiency through bulk production of LED bulbs, smart meters, and programs for labeling of appliances. This is a major area where we are trying to make a transition as far as the energy efficiency is concerned. Sustainable energy system framework is very important, because it's not only just producing energy, but it's important that we have sustainable energy system framework. That means all the three segments like electrification, critical to long-term carbon goals and will be a relevant distribution source, which will certainly require our focus on key technologies in terms of electric vehicles, vehicles to grid, home, smart charging, and heat pumps and things like that. Digitalization, which will allow us to open real-time automated communication and operation of the various systems, and new technologies which will be certainly making a difference and which are already on anvil are going to be the network technologies like smart metering, remote control and automation of the system, smart sensors, beyond the meter, and optimization and aggregation platforms, smart appliances, and smart devices. And IoT will play a major role in this particular segment. The decentralization becomes very important because we have seen that many of the energy production methods will not work in the bulk energy production system. So decentralization, which makes customers active elements of the system, though requires significant coordination, but it will certainly make a difference. And it will also give us permission, a lot of scope for energy efficiency like solar PV, distributed storage and microgrids, and also to modulate the demand response cycle. So these are some of the major pillars if we want to really make sure that we are sustainable as far as the energy system framework is concerned. And there are three goals. There's one goal and there are three objectives. Sustainable energy for all by 2030. This is the goal. In that, three things have to be ensured. That is, ensure universal access to the modern energy services. We need to increase. While India has done significantly well in the last about 5 to 7 years, that about 98 or 99% of the households have been now provided electricity and so on. The next one is energy efficiency, doubling the global rate of improvement in the energy efficiency. And that is one segment where India has to really make a lot of inroads. The fact that we have gone to LEDs, we have gone to smart metering and all that, I think we are making enough efforts, but I think it needs to be doubled. And doubling the share of the renewable energy in the global energy mix. That is another one which India is doing significantly well. But I think these are the three major objectives. If we can satisfy, we will achieve the goal of sustainable energy by 2030. There is an energy trilemma, as we call it, which is related to energy security, energy equity, and environment sustainability. What is energy security? It is the effective management of the primary energy supply from domestic and external sources, the reliability of the energy infrastructure, and the ability of the energy providers to meet the current and the future demand. So that becomes the energy security framework. Then when we talk of energy equity, it is basically accessibility and affordability of the energy supply across population. And that is the term problem is affordability. In fact, there are various means available today for making us, giving us more green energy. But affordability is a major issue in those segments. And that's why they are not finding place in today's energy mix. For example, hydrogen can certainly become a very clean source of energy. But then, as on today, I'm not saying what will happen tomorrow. As on today, its affordability is becoming a problem. So as a result, it has not found much favor as far as the current energy mix is concerned. But there is a lot of technological development going on to make sure that in future it becomes one of the major pillars. Same thing happens with the environmental sustainability, which encompasses the achievement of supply and demand side energy efficiencies and development of energy supply from renewable and low carbon sources. That is the most important part of the energy environmental sustainability. So from this point of view, if you notice, over the years now, there has been a tremendous shift, and this transition is taking place from what we used to have, and even today some of it is existing, are the low efficiency systems and producing high emissions, which is what is shown on this graph. You can see the left corner, the oil, coal and gas, which are the traditional energy production sources, exhaustible fuels that burden the environment. They are likely to also get exhausted over a period of time. So they are in that category, and they have been part of the low efficiency systems and things like that. Then we have now come over a period of time, what we call as advanced energy production systems, combined heat and power, and energy efficient and low emission products, with, of course, carbon capture and sequestration and utilization as becoming the major source, with improved energy efficiencies in the thermal power plants, in the boilers, in the distribution segment, and also switching over to much better alternate fuels, which are producing less emissions. So you have this segment, which is the middle segment. And nuclear also, of course, is finding a major place even today, because nuclear is one of the clean sources. But because of the cost again, and because of the time required and the capex required for setting up this, even today we can see nuclear today and tomorrow. Tomorrow it will increase. But if we are able to really get into the fusion as one of our aim, and also reach what we for a country like India, where we have a huge supply of thorium available, I'm sure nuclear tomorrow will become a major segment of the energy transition strategy. But most important thing what is emerging, we can see, is the solar economy. Solar-based production with high overall system efficiency is what is happening, and which is emission-free, where you get renewables like solar, wind, ocean, bio, and geothermal. These are the sources which are becoming most and more prominent. So this is a total change in the energy mix which is taking place over the period of time. There are 6 technology-based services can transform India's energy sector. Like, for example, unconventional oil and gas. That is, technologies such as non-water fracking, horizontal drilling, and fracture modeling enable recovery of the previously inaccessible reserves, including shale gas, coal bed methane, and tight oil. I'm not talking of that how do we actually overcome the problem of these shortages. You know that world over today, because of the low cost and abundant supply of gas in the US and many other areas, economy is shifting towards what is called the gas-based economy. But India doesn't have adequate resources of gas unless we really exploit our coal bed methane, and also our resources where the shale gas is available, by making tremendous changes and achievement in the technologies of fracking and horizontal drilling and so on. We will not be able to make use of these resources. So there's a requirement where the other part of the globe, they are already into it. Second was the photovoltaic solar, on-grid and off-grid PV solar can reduce use of carbon-based fuels, limit emissions, and bring power to the remote access. I think in this area we are working significantly well. But I think what is needed besides the photovoltaic, I think we have to look at what is called concentrated solar power, which is also going to give us distinct advantage in terms of efficiency and also less area as far as the solar power generation is concerned. Offshore wind, solar, and sea wind biofuels, which do not require land and fresh water, may become source of clean energy in India. In fact, this is one area where I think there's a lot of work going on, but I think a lot more is required to be done in terms of making it technology savvy, technology in terms of cost, and ensuring that there is durability when it is deployed in the saline environment over the sea surface or on the lakes and things like that. So we need a great amount of technology input in terms of materials and anchoring technologies and so on. But we have found that besides increase in about 3 to 4% of efficiency when it is deployed on the offshore, there is a significant amount of cost reduction because the land costs are also not included in this, which certainly is a very positive sign. Then, of course, smart metering, which enables demand and management schemes, low cost efficient advanced energy storage systems, because you will realize that while solar and renewables have got a tremendous advantage, but then the intermittency and things like that are a major problem, and which requires low cost and efficient energy storage devices like batteries, and which can bring power to remote areas, enable use of renewables, and make the grid more reliable. And in this respect, I think there has a lot of research required to be done. Not only batteries, there are other sources of energy storage, like fuels like methanol and things like that, which can be the energy storage, or ammonia for that matter, devices for future emissions. Energy efficiency. Energy saving measures such as use of CFL lighting, energy efficient irrigation pumps, raising efficiency of power plants and trucks and so on. These are major areas as far as things is concerned. Now, how each one of these selected technology applications in the Indian energy sector can have economic impact of something like $50 to $95 billion per year in about 2025. This particular chart indicates that, for example, unconventional oil and gas will give you a potential economic impact of about $10 billion. And it will also estimated potential reach into 2025 is reserves of about 130 trillion cubic feet and 9 to 10 trillion cubic feet per year in additional production. And less than 15% cost of conventional gas. That is what is likely to happen. If you take solar PV, you will get about potential economy of impact about 6 to 7 billions, 81 to 96 terawatt hours of energy. That's about 4 to 9% of the total electricity consumption, and about 45 to 50 million more productive people due to the electric city connections. Smart metering will give you another advantage of about 15 to 20 billion dollars. And certainly the losses will also come down. You will have automated meters, and 70% reduction in losses is what is expected. Social impact due to carbon emissions, which can be avoided, it will be in terms of 3 to 24 billion dollars, and 172 to 240 million tons of carbon emissions can be avoided, which will again lead to about 20 to 100 dollars per ton of carbon emissions avoided. Energy storage will give you 5 to 10 billion dollars advantage, in which about 10 to 20% more available for electricity due to advanced battery storage systems. Energy efficiency, you will certainly get an advantage in terms of about 15 billion dollars. Where energy intensity, you will gain from today's energy intensity factor of about 47 cents per kilogram of oil equivalent per dollar of GDP. It will versus today what is happening about 56. So it will keep coming down, and that will be the great advantage. So you see, this is the kind of impact which is going to make as far as the economy is concerned. So it becomes imperative that when we do this transition, we have to focus on all aspects of it. It cannot be just renewable, it cannot be just energy efficiency, but I think it is a complete triangle which has to be taken care of by all means what we are talking of. In this segment, I think India has done reasonably well as far as the renewables are concerned. If you see our growth from 2013, you can see that solar PV and onshore wind have seen growth, overtaking for the first time investment in the thermal power generation in 2018. To reach 175 gigawatts by 2022 and 450 gigawatts later, system integration becomes a priority. So this becomes that all kinds of systems have to be put on priority. You can see how the increase has taken place from this graph. Energy efficiency improved, but actually this is one segment where we have to accelerate the whole process. Strong programs based on National Energy Efficiency Mission, which were launched in 2000. Still, we have to go a long way in this. Where we have to focus on green public procurement like LEDs, Ujala program has already done. Industry schemes like Perform, Achieve and Trade, where like the fertilizer plants, we are talking of energy efficiency there. We are talking of energy efficiency in steel plants and so on. So there is a industry scheme which certainly promotes this. Cooling action plan is also there. Recent energy efficiency programs introduced since 2000 have allowed India to cut expected energy demand by about 15%. We have reduced our oil imports by 8% and gas imports by about 12%. We have lowered the carbon dioxide emissions by 300 million metric tons, or about 14% of the current emissions, and reduced local pollution in terms of SOx and NOx by more than 15%. So this is the kind of we have managed since due to the energy efficiency. With ambitious energy efficiency policies which will go up to 2040, I'm sure that about $200 billion per year of energy imports and about 300 gigawatts of new power generation can be achieved by this kind of a process. Now, how this energy transition is going to happen, and if we produce, if we do the penetration at what rate, how it is going to impact. The two blue lines are shown as a minimum demand scenario and the maximum demand scenario. And the gap between them is how much of it we can achieve through the penetration of the renewable. If you see the renewable production in the first graph, you can see a small renewable production, which is the low. You find that our most of the demand is not met by this kind of a thing. Renewable is much lower than the minimum demand. When you go to high renewable penetration, you see renewable production has improved, and as a result, you are able to meet the minimum demand, and part of the maximum demand. If you go for 100% renewable penetration, you will find that we are fairly well off as far as the total production is concerned. We can meet most of our maximum demand. So this is the kind of penetration if we can achieve, we will be able to achieve the kind of energy mix which will take us into a very low cost domain as far as the energy production and supply is concerned. Now, energy efficiency can help drive economic prosperity. We also talked about those numbers earlier, but this clearly gives how the other countries have achieved GDP in efficient world scenario versus new policy scenario by 2035. You can see Japan, Korea, which are less than about 0.5%. And whereas India, if we are saying we are reaching almost about 3% gain. So cumulative investment in energy efficiency of about $12 trillion are more than offset by fuel savings and can trigger economic growth of a cumulative about $18 trillion. That is a kind of international energy scenario agency has worked out if we really focus on energy efficiency technologies in terms of the economic prosperity. So this is one area I think we are doing well, but I think we have to do better. There is a need for us to do decarbonize the energy sector, as we have seen the way transition is taking place, because CO2, we have said that about 70% reduction has to take place by 2050, and for that, then only we will be able to keep the global temperature well below 2 degrees or 1.5 degrees Celsius beyond the industrial base. So for that, first thing is drive in renewable energy cost reduction. We have already seen that the renewable energy, particularly PV, has come down significantly, but coming down to about, I'm talking of the cost without storage, to about 2.5 rupees per unit. I think it will still need further lowering, and particularly with the energy storage in the segment. Wind turbine costs reduced by about 30 to 40%. This is the kind of scenario which has taken place. Now you say enhanced technology performance. Today's renewable energy technologies need to give what is called renewable energy share about 12% yearly to reach about 2050 climate goals, and could provide about 2/3 of the world's primary energy supply. But then everybody asks, if you are only 2/3, how do you meet the demand of the 1/3? And that's where the energy mix becomes a very important aspect. We also have a third technology innovation requirement: integrate high shares of renewable energy in the power systems. And as I mentioned to you, because of the intermittency of the renewable systems, it is important that we have new ways to operate systems, innovative business models, and enabling technologies like grid balancing, smart meters, smart grids, and so on, and very strong energy storage devices. Create breakthroughs. Fourth one is for end-use sectors. Find affordable solutions. For example, we have developed low-carbon technologies for aviation, heavy industries, road transport, and shaping. There is action needed now, and these actions are for all, like government, encourage private sector innovation. And developing new technologies requires decades of R&D, demonstration, and market. So this needs to be supported. Innovation goes beyond technologies in creating new business system integration, wealth creation, and that is the need of the hour today. We need to support all these segments. India is working on clean coal technology in a big way today. We have a very strong program on advanced ultra supercritical thermal power plant and combustion. So you can see the advantage in all segments like pulverization, gasification, and different technologies, or like for gasification like fluidized bed. In each one of them, along with the when you are supercritical, you get about 40 to 45% ultra supercritical. Midterm, when you go to advanced ultra supercritical, you get about 45 to 50 with oxy fuel, and then if you add to all of them the carbon capture and sequestration or utilization, I think you get a long-term efficiency of about 50%. So that means these are the areas in which we have to really make major progress, and India is really working in that direction to go for oxy-fuel systems as much as possible, go for CCS, CCU, and also go for advanced ultra supercritical. This is very important for a country like India because we have huge reserves of coal. We cannot afford to go for gas-based economy in a big way because import, whether you do for crude or you go for LNG, is an import. And whereas you have coal reserves, while you have high ash content coal, but I think today's technology have found solutions for even converting high ash content coal in the form of energy what we are looking for by using the fluidized bed gasifiers, co-firing and coal and petcoke mixing, and variety of other measures by which you can get good energy output from the high ash content coal. I think we have to work on those areas. Besides, of course, that now we have a major push which we can give on carbon dioxide sequestration and utilization. All our flue gases coming from steel plants, our cement plants, from our thermal power plants, I think they need to be subjected to the CO2 capture because these are the bulk producers, CO2 capture, and then converting them into alternate fuels using the hydrogen which will be produced from the renewable energy. And also go for not only alternate fuels, but we can also go for hydrogen production and things like that. So and chemicals for that matter. So there's a huge scope for us now to combine these clean coal technologies into the complete economic cycle, which will, with the technology inputs as they are emerging, to achieve the complete hold on these emissions. Biomass is one more segment for India because this is one segment which is again renewable in that sense. We produce almost about 1,000 million tons of biomass, and even if we take biomass potential is almost about 150 million metric tons per annum, and even if you take about 1/3 or 30% of this, we can produce as much about 2.6 to 3 gigawatts of power, and that will also not only produce power because most of the biomass energy production is decentralized from the point of view of supply chain problem. We have a huge job, that's employment generation to the tune of 120,000 jobs across the country can be conducted. So biomass energy perspective is a very positive perspective, both from the Swachh Bharat point of view, Atmanirbharta, as well as employment generation. And technology is well within our reach. There is no problem of producing whether it's a biogas or bio-CNG. All of them today are well within our reach, and we can certainly make a major difference. And all these pathways which I have shown today, India has done reasonably well in all of them, whether it's gasification or it is pyrolysis or the anaerobic digestion or fermentation. I think the academicians have come out with all the processes using the variety of feedstocks which are listed here. And we have been able to produce methanol, we have been able to produce bio-CNG, biogas, and there is a 1G and 2G ethanol also is being produced by some of the industries in the country. The only problem in this segment is still the management of biomass-based energy production. We have not been able to achieve the required efficiency because of the supply chain problems and also not having a proper business model in which the participation of the biomass generator is taken on board for ensuring that the biomass prices don't go into volatility mode, making the system economically unviable over a period of time. So I think there's a huge segment of that. A good business model, scale of operation, and also distributed biomass energy generation is what the order of the day we should work in that direction. Global solar generation will go from 1% to 30% consumption. We discussed that. So what should India do as far as the solar is concerned? I think we should look at our best strategy should be that we should go for a small size distributed generation plants in large numbers with and without grid connectivity. This is one area because India still have a huge area where we are not able to put mega plants. Then strategy 2 is hybrid solar with large size thermal power plant. And strategy 3 is we go for large size CSP plants, more than 10 megawatts clustered PV and CPV, which will certainly order of the day in places like what we have shown in this the Northeast. And then we, of course, direct solar cooling and heating. Tropical nature of solar radiation and non-availability of large and mass puts different challenges in India, and that we should try to get. As I was mentioning to you, hydrogen is the main source and it is going to the fuel of the future. It is important that the hydrogen economy is given the necessary push. So when we talk of hydrogen economy, it has 3 segments today: production, storage, and usage in the fuel cells. Production, of course, can be from a variety of sources like splitting water, solar wind as a source of energy, nuclear energy, fossil fuel reforming, bio-inspired hydrogen production. Our goal is today we are talking of 9 million tons per year, but actually our requirement in 2040 will be of the order of 150 million tons per year. So it becomes very important for us to find ways and means of producing hydrogen at affordable cost, and that is where we are looking at. World has put this cost scenario to the tune of, if we are able to bring it to the level of about $2 per kilogram of hydrogen, then I think we'll be able to match this with these kind of gas prices which are existing today. So our effort, which is right now, if we do, we have come down to about $6 to $7 in some cases. I think we have to bring it down to about $2 by innovative methods of technology and also a scale of operations. Storage is another area which is a major issue, in which you will notice that there have been major attempts in terms of pressurized storage going up to about 700 bars. Hydride storage in terms of variety of hydrides which have been done, but unfortunately hydrides have not yielded the kind of performance in terms of volumetric and the weight percentages which can be stored, and also the energy required for recovering the hydrogen from the hydrides. Still it is not a net negative system, so we need to put more energy into it. So storage is another segment where you have, for example, if you take storage of gas at about 10,000 psi, you will get about 4.5 megajoules per liter. If you put it in the form of liquid hydrogen, you will get in the form of about 8.4 megajoules per liter. Whereas our goal, which I used to talk in 2015, is about 9.7, and we are still struggling to reach that value. Third area is ultimately when you use hydrogen for generation of power, is basically fuel cell. The fuel cell today has become a positive area, is that the cost of fuel cells, which used to be significantly high once upon a time in terms of per kilowatt of energy production, about $3,000 per kilowatt, has come down to as low as about $400 per kilowatt. But IC engines produce it at the cost of about $30 per kilowatt. So obviously for us to come back to the levels which we are used to, there is still a lot of work is required as far as the fuel cell technology is concerned. And hence we need to really work in that direction. So hydrogen clean energy carrier as one of the most essential clean and sustainable resource with main application in both research and industry. You can see in this diagram, you have got energy resources using natural gas, renewable resources, wind, solar, biomass, hydro, nuclear, coal with carbon sequestration and utilization. Will produce hydrogen, which will clean energy carrier, can be used for fuel cells directly in the engines and turbines for energy production, or in terms of energy storage, in terms of methanol and so on. Then you have got petroleum recovery and refining, 47%, methanol production about 4%, electronics, ammonia production about 45%, and metal production about 2%. So there's a significant amount in which the hydrogen can be. So when you look at hydrogen, it should not be looked at only hydrogen production. I think the complete island should be looked at when you do the techno-commercial analysis. Many times people will say hydrogen produced from electrolysis is still not affordable. But friends, you should also look at the value which it will add if we use it in producing chemicals and so on. And then you take the overall value added cost, then you will realize that it makes a lot of economic sense for using hydrogen even in today's scenario. Hydrogen on the global horizon, countries with hydrogen missions are Japan, USA, China, European countries, And automotive industry, there's a significant amount of effort being made by Hydrogen Council, which was formed in 2017, with about 1.5 billion investment on development of fuel cell electric vehicles by Toyota, Hyundai, Honda, BMW, Tata, and Mercedes, and so on. In fact, in India also, our FAME2 program, unfortunately, fortunately, it includes hybrid vehicles, but it does not give even today the kind of tax subsidy, whereas electric vehicle is getting 5% tax. The hybrids are not getting, which is the main reason why the hybrid vehicles are not finding that much of penetration in the country. If we can get hybrids electric vehicle, you will notice that there will be a significant change. So you will have fuel cells coming in, you will have electric vehicles coming in along with the IC engines. You will have a distinct advantage in getting that. So hybrid is actually the route to reach the ultimate fuel cell based economy. Globally, socially responsible investment surged 34% to about 30.7 trillion over the past 2 years as far as hydrogen is concerned. So clean hydrogen could cut up to about 34% of the global greenhouse gas emissions from fossil fuels. Renewable hydrogen could be produced for $0.8 to $1.6 per kg in most parts of the world by 2050. That is the way I was talking about $2, and this is the way people are talking about. This is equivalent to gas price about $6 to $12 per MMBTU, competitive with the current natural gas prices in Brazil, China, India, Germany, and Scandinavia. When including the cost of storage and pipeline infrastructure, the delivered cost of renewable hydrogen in China, India, and Western Europe could fall to around $2. This is what I was talking to, $2 per kg. That means about $15 per MMBTU in 2030. And it is expected that this will come down to about $1 by 2050. Now, I am addressing to a large number of academicians and industry partners and some of the researchers. I think there's a very, very specific requirement in our country to work in this direction to bring down the cost figures as we are talking in the context of Indian technology. And that is where we will be able to score. I am a proponent of methanol, so any I cannot stop and talk about methanol. Here also I am talking of saying that fully electric powertrain face challenges. Only a fraction of transport can be fully battery powered, which is shown here. By 2030, some cars, 2 to 3% will be about commercial vehicles. And as far as the marine and aviation sector is concerned, there will not be anything. Whereas if you take power to methanol, you will have fuel for road transport and shipping and potential feedstock for jet fuel. So this is the advantage of methanol. Then you take matching intermittent source and EV charging challenges. You have, as I was mentioning to you, the intermittency, then meeting it with the EV charging challenges, which will be again a major requirement, will be with about 175 gigawatts of renewable energy to be matched with the demand of the energy which will be required for charging and things like that. It is a major task. Whereas this can be integrated with grids, industrial production plants can take better use of the electricity from non-dispatchable sources. Then challenging to ramp up sustainable battery production. If you want to really look at, can we make this many batteries? If you take in 2019, number of car registration that took place is about 21 million. Battery requirement for new cars itself will be about 2,100 gigawatt hour. So scalability is a major issue. And in this case, as far as methanol is concerned, there are no such issues. As I was mentioning to you, when we compare today in the energy segment, mobility segment particularly, we have three candidates. One is, of course, the present gasoline and IC engines, which are probably having the, in spite of BS6 and so on, we have still the greenhouse gas emissions, and of course, our dependence for producing these fuels on import. On the battery EV, you have limited range. We have a charging time issue. We have packaging issue for large vehicles. We have performance affected by weather. Despite all the technologies that has emerged, even today, I can't say that lithium-ion batteries will be safer to use in environments like Rajasthan and Gujarat, where temperatures can go as high as 55 degrees, 52 degrees, and so on. And we still have problems to solve with respect to the temperature suitability. Whereas fuel cell, you have long range, quick refueling, limited weather impact, scalable to wide range of vehicles, zero emissions, high fuel efficiency, instant torque, quite domestic fuel source and so on. In fact, I was giving a figure that if you have, lithium-ion battery, it is equivalent to burning the emissions, well-to-wheel emissions for a lithium-ion battery operation, including the charging, is equivalent to burning about 35 kilograms of gasoline. So people generally get misled by the fact that tailpipe emissions in the battery operated vehicles is zero, but actually we have to look at the complete cycle, and that's why well to wheel emissions are more important, and which is equal to almost about burning 35 liters of gasoline. So if that is a number, then do you really have the advantage of greenhouse gas emissions as far as battery EV is concerned? Many people have debated on this issue, but I have my strong opinion on this. Fuel cells, as I mentioned to you, technology is building, and now with the SOFC and also EC coming in a big way, and the cost of the thing like the PAM has come down, and India also have done fairly well as far as the phosphoric acid fuel cells are concerned. They have been able to put it in submarines today. I think fuel cell with molten carbonate or the solid oxide fuel cells will certainly make a great day. Some of the Indian industries like what is called element H2E and element, I think, Pune companies, they are doing reasonably well as far as the fuel cells are concerned. Even Ballard is doing well in India. So I think this is one area, but still there's a scope for technologically bringing down the cost, because the kind of catalysts which we are using today are still platinum-based catalysts in many cases. If we can reduce the cost and find alternate by finding alternate cheaper materials for the catalyst, and also go for better cheaper materials for the membranes which we are using today, particularly for high temperature applications, I think it will be of great value in reducing the cost of the fuel cells. I have a point which I say that methanol, if you take, can be reformed into hydrogen by over a catalyst, and hydrogen plus carbon dioxide, and carbon dioxide can be adsorbed on any of the what we call as the molten framework. So you get PEM, and then using a PEM we can generate power. Advantage is methanol is it doesn't require much energy because it can be reformed at reasonably low temperatures around 250 to 300 degrees centigrade. So even onboard reforming and storage of hydrogen is not a problem, not in the liquid form, but in the form of gas. And using that online, we can run in this diagram as I have shown. You have fuels like methanol, then you have a reformer, you put it on a fuel cell stack, and then you generate power. So a thorough study shows that hybrid design with charging done via methanol will settle many challenges of the pure play battery, even within a metro drive case. And best possible way e-mobility can happen is on the back of methanol-driven fuel cells. Both CO2 emissions and least disruptions to the infrastructure occur with these options. And even the heat which is generated from the fuel cell stack can be made use of for vapor absorption cycles for heat pumps and the machine. So that is what we can do. Another thing I was mentioning to you is the carbon dioxide sequestration and capture. So flue gas is captured and use solar energy, whether it is parabolic dish or solar PV, what we call as a solar engine, take carbon dioxide, take water, create syngas, hydrogen plus CO, and then liquid fuel production, methanol or Fischer-Tropsch fuels and so on. So this is one area, I think if we can really do a good job using the solar energy, one will be in a position to get over this problem of carbon dioxide capture and utilization. Gone are the days when people used to talk of putting it in the ocean beds and all that. I think this segment of activity, if technologically flourished, will be able to give us the required what we call a net carbon neutrality, and also ensure that CO2 in the atmosphere is made use of rather than being allowed to do the pollution. You know that electricity and hydrogen are complementary. You can use hydrogen infrastructure for production like gasification and reforming. You produce hydrogen, which can be used in chemical industry, and surplus hydrogen can be again made use of hydrogen infrastructure for mobility of the cars, fuel cells, hydrogen fuel IC motors, stationary heat and electricity generation, and so on. Electricity, of course, power generation solutions like from fossil fuels, fossil CO2 power generation, renewable power generation. And this electricity is again used for hydrogen production. So you have a hydrogen infrastructure and electricity grid, because electricity grid can be used for the battery-driven cars, for electric motors, and so on. So you have a very good combination between the hydrogen and electricity. So these are the two energy carriers which are complementary. Geothermal energy is one segment which India has not paid much attention, but India has got huge results. This diagram shows where we have all the operations available. We have huge, right from Kumayu to Kargil. If you go along the Himalayan foothills, you will find we have got huge reserves of what is called the geothermal. We should exploit this. We have done experiments. Even when I was in DRDO, we were able to drill a well, and we got about steam at about 16 bars at a temperature of about 140 to 160 degrees Celsius. And if you can do it organic Rankine cycle kind of an approach there to produce heat electricity, in areas like Leh, Ladakh, where availability of electricity even today is a problem, geothermal should be our route, because while the efficiency is not very good, but I think the cost of producing is going to be much lower, and it is going to be totally renewable. So I think we should do our great amount of work in this direction. Artificial intelligence is going to play a major role in the years to come, both in terms of power grid, smart grid, sector coupling, virtual power plants, AI for power consumption, smart home, smart meter, and AI in the electricity trading in terms of forecast, algorithmic trading, and monitoring trading. And India can almost double the number of jobs to the power sector by 2030 by following an ambitious decarbonization plan. For example, 2020, we have 1.24 million. And this is a scenario that highlights the strategies necessary for achieving the targets laid out in India's international climate commitment. By 2030, if we do, we will have about 1.6 million, and renewable 2030 roadmap, we will have about 2.3, and fully renewable about 3.6 million. So that is a kind of scenario when we have high ambition renewable energy roadmap in India, which has been indicated by the international committee. So immediate actions needed at the sector level to transform the global energy system. Power sector, accelerate the renewable capacity additions to generate adequate power with low carbon technologies. Update grid planning to accommodate rising shares of variable renewables, solar and wind and energy. Support distributed energy resource deployment. This is one area where India has not done well. We are not supporting distributed energy. I think we should do that. And particularly the remote corners where the reach is still a problem, we should go for distributed energy generation and distribution. Transport sector, reduce transport volume and congestion, accelerate the shift to electricity mobility. Priorities should be biofuels in the road, freight, aviation, and shipping. In fact, I'm talking about marine aviation. Marine, we should certainly go for methanol as early as possible. Industrial sector, reduce energy consumption industries, enable corporate sourcing of renewables, and accelerate low carbon technology deployment for industrial process heating. Building sector, we should reduce the energy consumption in buildings by going for green buildings, support and foster distributed energy resource development, and scale up the renewable share in the building sector also. So this is the way forward in terms of policy 2030, where energy and climate policy of 2030 is there, sustainable investment plan, new investment in airports, rail, urban infrastructure, capital markets, and innovation, circular economy, digital single market, change in consumer behavior, all of them are the way which we are looking. Actually, for energy sustainability is the power sector needs to be transformed to accommodate growing shares of variable energy. Digitalization is the key enabler to amplify the energy transformation. This is second one. accelerate the electrification of the transport and heating sectors for crucial for the next stage of the energy transformation. EV charging infrastructure must be supported. Alternate heating technologies such as heat pumps in industry should be promoted. Electricity and end user sectors must be coupled. Hydrogen produced from renewable electricity could help to reduce fossil fuel reliance. It is important to set up stable and supportive policy framework in this direction. By the way, Niti Aayog is doing wonderful initiative as far as hydrogen economy is concerned, along with MNRE and other ministries. I need the academia and the industry to participate in this mission hydrogen, so that we don't look at 2050. I think we should be looking at 2030. In 2030, we should be fairly, aggressive hydrogen economy in the world. Supply chains are key to meet the growing demand of sustainable energy. Bioenergy must be produced in ways that are environmentally, socially, and economically sustainable. In sectors such as shipping and long-haul road transport, biofuels must be the main and only option for decarbonization for years to come. Targeted attention and specific policies must be devoted to these sectors. Decarbonizing the energy system requires swift and decisive policy action also. Policymakers need to establish long-term planning strategies, define targets, and adapt policies and regulations that promote and shape a decarbonized economy. We can't be waxing and waning. We need to have a very stable policy on these matters. Policy should create the right conditions for investment in energy efficiency, renewable energy supply, grids management, EV charging, and storage. Close cooperation between public and private sectors will be the key. To meet a world powered completely by sustainable renewable energy, we would use approximately 1% of total Earth's surface, an area approximately the size of the Canadian province of Cuba. This is what we are talking of: zero emissions with hydro, wind, renewable energy, solar, hydrogen, and geothermal. And these numbers are staggeringly high. 3.8 million, that is 5 megawatt off and onshore wind turbines. 49,000, that is 300 megawatt of concentrated solar power plant. 40,000, which is about 300 megawatts solar photovoltaic power plant. 1.7 billion, which is about 3 kilowatt rooftop PV systems. 5,350, which is about 100 megawatt of geothermal power plants. 270 new, about 1,300 megawatts of hydroelectric power plants. 720,000, which is about 0.75 megawatt wave energy devices, and about 490,000, 1 megawatt of tidal turbine. These renewable sources would produce 17 trillion watts in total. This is the way, if we make investment, if this is a kind of a mix if we can make, we will certainly not have to worry about the fossil fuels. We don't have to worry about all the dirty fuels which are there, and we will have zero emission kind of a scenario. Thank you very much, friends. I think we need to really work together, and this platform will certainly enable all of us to give a strong thinking in terms of the pathways which have to be followed for research, development, and production of all elements for renewable, sustainable, and energy efficient system in the country. Thank you very much, and wish the organization all the best in the future to come. Thank you very much.
Thank you, sir, for a very, very exhaustive and bird's eye view of the energy scenario and what is the way forward, giving the vision. We're really grateful for your time and your support to ISEES. Sir, would you mind if we can take a couple of questions from the audience?
Welcome, welcome, welcome.
So there's one question from Professor Gautam Kalkatki. He's asking what actual and practical steps are in place to bring on methanol production using coal and solar energy.
Yeah, as far as India is concerned today, besides doing some R&D activities in coal gasification, we have already now taken steps for producing methanol using coal. One plant is being set up at Talcher, another plant is being set up at Dankuni under the aegis of Coal India. And India today has a major program for coal gasification, which has been launched by the Coal India and the Coal Ministry, where we have identified 4 more new sites where the coal gasification particularly the low quality coal gasification will be attempted. And we are working in collaboration with international agencies like Air Products and so on to bring in the necessary technologies for this, which will enable not only the production of methanol, but large number of chemicals. So it's a full island, as I was mentioning to you, coal gasification with carbon dioxide sequestration, syngas generation, syngas to methanol, syngas to ammonia, and syngas to fertilizers, and syngas to other chemicals. This is the kind of scenario which India has planned, which is going to be up to 2040. We will have a major focus on methanol production and methanol utilization. That is coal-based. Another one is a biomass-based methanol production is also being attempted, where distributed biomass will be followed. It is going to be bio-CNG as well biomass. This is the kind of and methanol based on biomass. So this will be another area which is being pursued today, as far as methanol is concerned. We are, as on today, not focusing on gas-based production, because while my existing plants are all gas-based, but expansion is taking place in that area because gas is imported at a lower cost today, and it is making methanol production globally competitive. So they are augmenting capacities for gas-based production of methanol. For example, Assam Petrochemical has augmented their plant capacity to about 600 tons per day from what they had 100 tons per day. And that is a kind of scenario which is emerging as far as some of the other plants are concerned. But I think slowly we will switch over to the coal-based. And we find that if we go to the right scale, we will be globally competitive. While the prices of methanol have come down in the past as low as $250 to $200 per ton, I am quite certain that we can match it, provided we do the coal gasification at lowered capex and also lowered operation costs, which is again a technological challenge.
So there's another question which is about the methanol economy as well as hydrogen economy. Which you think is going to come first, and what will be the contours?
I personally believe that they are friends. Methanol and hydrogen are two friends. Actually, methanol is a carrier of hydrogen, and methanol is a chemical which can be used for a variety of applications. But in my opinion, if we have to solve in the near future the problem of hydrogen storage and hydrogen utilization on board any commercial vehicle, methanol is the route, because today already methanol reformers have come in the market. And Thermax has built a methanol reformer, although it is slightly larger footprint, but there is a lot of scope for reducing the size. And even with this footprint, I can see that it can be made use of in at least commercial trucks and commercial vehicles where the space is no limitation, weight is not so much of a limitation for running a fuel cell based cycle. So you can store methanol, you can produce methanol on board, produce hydrogen on board using the reformer, and then have the complete e-mobility drive chain using a fuel cell for driving the same. So actually we are wanting to do this. And the same thing we want to do for the marine engines today. And the marine engines also we are looking on the same direction. Of course, we have a direct option also that we can have methanol, and methanol directly can drive a methane IC engine. This is one option. Another option is methanol, hydrogen, and then driving the hydrogen turbine. And third option is methanol, hydrogen, and then driving a fuel cell. So all the three segments are being pursued where methanol will play a significant role.
So when do you think the methanol economy will be adopted on a commercial scale in India?
I think I personally believe that in the 2021, we'll see that the 15% blending of methanol will certainly be the order of the day as far as the automobiles and particularly the two-wheelers, three-wheelers, and the four-wheelers are concerned. You will find that this will get accepted. We are only waiting for adequate supply of methanol to get place. Otherwise, right now, if we launch this program in all parts of the country, we will have difficulty and we will not be able to survive without import. because our indigenous production capabilities are limited. So we have launched this program today in the eastern region, where Assam petrochemicals production will be good enough for meeting the requirement of blending 15% in the northeastern region. But if you want to do it in the western region, other places, the existing plants like RCF or the Gujarat fertilizer or Gujarat Narmada fertilizer or Deepak fertilizers, they have to augment their capacities. We are working with them. Hopefully, that will be another segment where we would like to launch it in near future. But coal to methanol, the moment it becomes a reality, which will take about 3 to 4 years, I think then we'll be in the full-fledged methanol economy program. I see 2025 could be a possible date where we can have good methanol economy taken, both as a cooking fuel as well as a automobile fuel.
Thank you, sir. Over to Professor Pandey.
Thank you very much, Dr. Saraswat. It has been very enlightening lecture, and I'm sure a lot of us have quite now further inputs in terms of statics, what you have provided, in terms of perspective, especially for India. And there are a lot of questions still to be answered, and this is where the society and its pillar are trying to make effort to move into right direction, whether it is a biofuel, whether it is a methanol, whether it is hydrogen-based economy, whether it is IC engine, or whatever it could be. In fact, we have a lot quite debate among ourselves about the hybrid, system, including e-cars, e-vehicles, etc. So your lecture has certainly provided a lot of further knowledge as well as gains to us, and we look forward for working more systematically and in more scientific manner for a technological perspective for the country as a whole. Thank you very much for your time and your kind blessing to society as usual.
May I now, sorry. May I now invite Dr. Akhilen Pratap Singh to kindly propose a vote of thanks.
Thank you, sir. So, Honorable Dr. V.K. Saraswat, Member Niti Aayog, respected Professor Ashok Pandey, Chairman ISEES, our most valued guests, speakers, and participants. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of ISEES and the entire organizing committee of 5th C, and my own behalf, extend a hearty vote of thanks to all our chief guest, Dr. V.K. Saraswat, for accepting the invitation at short notice. Dr. Saraswat has been blessing the ISEES conferences as its patron in every conference. I would like to thank all speakers for accepting our invitation. I would also like to thank all conference conveners, Dr. Pravesh Chandra Shukla, Dr. Swatantha Pratap Singh, Dr. Anil Kumar Patel for their efforts. A big thanks to all the volunteers from IIT Kanpur, from IIT Bhilai, and from IIT Bombay for their hard work in organizing this conference. I would also like to thank all others who have contributed directly or indirectly in organizing this conference. Thanks.
Thank you. Thank you.
Thank you, sir. Thank you very much, sir.
Thank you.
So I'll take your leave. Thank you very much.
Yeah, we close this opening session. Thank you very much, Dr. Saraswat. Thanks, everyone.
Thank you, sir.
Thank you.
Beginning to